Okay, good morning to all of you. In this class, we are going to discuss divergence in terms of orthogonal collinear coordinate system. In our last class, we have been discussed in detail about gradient in terms of orthogonal collinear coordinate system. Before that, in detail, we have been discussed what do you mean by orthogonal collinear coordinate system. Okay, so in our today class, we have to discuss divergence in terms of OCCS means orthogonal collinear coordinate system. So let's start. So to derive the divergence in terms, so here you can write to derive the divergence of a vector field. We know that one the divergence should be divergence of a vector field, right? Of a vector field. Divergence of a vector field in terms of orthogonal collinear coordinate system. Let us consider a vector function which is a function of u, v, w, where u, v, w are the curves which are intersects at a particular point where the normals, sorry, tangents from that point will be orthogonal with each other. Okay, so a is the function of curve u, curve v and curve w in your OCCS system or orthogonal coordinate system. Now here A will be A1 E1 cap, A2 E2 cap, A3 E3 cap, where A1, A2, A3 are components along the unit vectors E1 cap, E2 cap, E3 cap respectively. As we have been discussed, this E1, E2, E3 are the unit vector along the tangent. This one is your unit vector E1 cap along the tangent for U curve. E2 cap along the tangent unit vector along the tangent of V curve. E3 cap unit vector along the tangent for W curve. These things already we have been discussed. And also we know that they follow these relations because these unit vectors are orthonormal with each other or perpendicular with each other. So E1 cap cross E2 cap will be E3 cap, E2 cap cross E3 cap will be E1 cap, E3 cap cross E1 cap will be E2 cap, and the dot products of self will be 0 and dot products with the other will be dot product with self will be 1, dot product of others will be 0 because they are perpendicular with each other. So here instead of E1 cap we can write E2 cap cross E3 cap. Here instead of E1 cap E2 cap cross E3 cap we can write. Similarly instead of E2 cap we can write E3 cap cross E1 cap. Instead of E3 cap we can write E1 cap cross E2 cap. Now that implies a vector will be A1. Here E2 cap can be written as H2 del V. You just go through your previous note whenever we have been discussed last class. I am telling you about the last class. Gradient in terms of orthogonal coordinate system. At the end we consider the note for phi equal to u. The value will be del u equal to E1 cap by H1. So E1 cap will be del u H1, E2 cap will be del v H2, E3 cap will be del w H3, right? So here instead of E2 cap we can write E2 cap equal to H2 into del v, E3 cap H3 into del w. So likewise here you can see E2 cap will be substituted by H2 into del v, E3 cap will be substituted by H3 del w, and E1 cap will be H1 del u, right? So here you can see E3 cap will be H3 del w, E1 cap is your H1 del u, E1 cap H1 del u, E2 cap H2 del v. This is your v. Okay, this is your v. Here in this note I have been represented v as like this. Okay, u was like this. So carefully you have to watch and write down your note, right? So this is your del v. So in bracket what I explained previously, we found u1 cap, u2 cap and e3 cap. So that implies a vector will be, here you can see from h, here h1 h3 are constant taken outside, a1 h2 sorry h2 h3 taken outside, so a1 into h2 h3 del v cross del w, a2 h3 h1 a2 h3 h1 del w cross del u, a3 h1 h2 del u cross del v. Okay, now we have to consider the divergence of this vector function. So divergence means del dot a, del dot left side if you have considered del dot a, right hand side also del dot this much term, simply I have been written. So this divergence, that means del dot can be operate on this term and this term. So del dot this term, del dot second term here I written, del dot third term here I written. Let this is your equation number 1. So separately we have to find the first term value, second term value and third term value, and at the end we have to just add up them, right? So for that first you have to consider one vector identity or property that already we know in our previous classes, that is your del dot phi f. In general, when the divergence of a scalar multiplied with vector, if you are going to consider, that means del dot phi f, that is nothing but phi del dot f plus del phi dot f. Let this is your equation number 2. Now consider first term of equation number 1. Here you can see this is the first term of equation number 1. Here you can see the in this first term, this is a fully scalar term. This is a fully scalar. So if I am going to match this term and this term, here del dot, here del dot. This is a scalar, this is a scalar, and this is the cross product of two vector. That means itself a vector. So here is the vector. So by considering this vector identity, the first term of the RHS of this equation number 1, first term of the equation number 1. Now consider here you can write, now consider the first term of RHS of equation number 1, RHS of equation number 1. That means first term of RHS of equation number 1, LHS is this one. So if we are going to consider del dot this one, then what we can write, by considering this vector identity, it will be written as, here you can see scalar del dot that vector. So this is the scalar, will be simply will be written over here a1 h2 h3 del dot this vector, right? Plus here you can see del phi dot f. So del phi means this scalar, a1 h2 h3 dot this vector. Here you can see del phi dot f. So here we have to write del, this is the scalar, dot this vector, right? Okay, now again from vector identity, it is also well known that del dot b cross c equal to c dot del cross b minus b dot del cross c, that we know. Okay, so therefore here you can see that del dot del v cross del w, if we are going to consider, then it will be how much, del w dot del cross del v minus del v dot del cross del w. How it is, you just compare this left hand side with this one. Here del dot b cross c, this is your b, this is your c. So first right hand side should be c dot del cross b. So what is the c? C1 is the c is this one. So this one del w dot del cross b. Del cross b means del v minus b dot, b means this one, del v dot del cross c. Del cross c is your del w. Okay, now that implies del dot a1 h2 h3 del v cross del w will be will be equal to, here you can see this one, I am considering this one, okay, this one, that implies this one, this value will be equal to, here you can see a1 h2 h3, a1 h2 h3. Now if I am going to consider del dot del v cross del w, then this value is nothing but this one I have written over here, right, plus del a1 h2 h3 del a1 h2 h3 del v cross del w, okay. So this term just written over here, right, but del cross del v and del cross del w equal to 0, okay, that we know very well, because del v and del both are same direction, so cross product will be 0. Similarly del cross del w will be also 0. So here you can see that del cross del v, del cross del w, these two terms will be 0. That means this first one, this whole term will be cancelled out, right, right. So therefore del dot this much will be equal to first term will be 0 plus second term whatever is there has been written over here, right. So that implies del dot a1 h2 h3 into del v cross del w is equal to see here del of a scalar, this is itself a vector dot this is itself a vector. So only for that if I am going to write a dot b, this is not this is also can be written as b dot a, no problem, right. So likewise here this is the vector and this is another vector, so this vector dot product can be written as this dot this, otherwise first you have to write this one del v cross del w dot this term, no problem. Let this is your equation number 4, right. So that implies this one del dot a1 h2 h3 del v cross del w will be equal to this one dot del phi. Here you can see that this is in the form of del one scalar, right, del phi. So del of a1 h2 h3 can be written as this one. Why and how? Here you can see we know that gradient of a scalar function in the term of OCCS is nothing but 1 by h1 del phi by del u e1 cap, already we found 1 by h2 del phi by del b e2 cap, 1 by h3 del phi by del w e3 cap, that we know, okay. Also we know at the end that del u equal to e1 cap by h1, right, and del v equal to e2 cap by h2 and del w e3 cap by h3, that also we know. And here you can see that if del phi equal to 1 by h1 del phi by del u e1 cap and e1 by h1, here you can see e1 by h1 is nothing but how much, del u. So this one can be written as del phi by del u del phi by del u. Likewise this one can be written as del phi by del v plus del phi by del w, right. Hence similarly if we are going to consider this phi scalar function will be a1 h2 h3, then what we can write this one, here you can see del by del u of phi, that means del by del u of this one a1 h2 h3 del u, then del by del v of phi, that means del by del v of a1 h2 h3 del v, this one del by del w of phi, del by del W of A1 H2 H3 and del W. Let this is your equation number 5. Now consider terms of RHS of equation number 5. So RHS of equation number 5 have three terms. See, this vector dot this one, this vector dot this one, this vector dot this one are the three terms. So first term we are going to consider, that one is your del V cross del W dot this term, this term, this term, this one not equal to 0. But second term you just concentrate, del V cross del W dot this one dot del by del V of A1 H2 H3 del V, del V will be equal to 0, because here you can see that del V cross del W is the is another vector which will be the perpendicular to this vector del V, right? We always know that A cross B, if C, then the C vector is all perpendicular to both A and B. Likewise here del V cross del W, whatever the vector we are going to get, that vector will be the perpendicular to del V, right? Again, if I am going to consider this vector dot product with del V, then we are going to get the 0, because both are perpendicular with each other. So I written clearly here del V cross del W dot this much, that means this one will be equal to 0, because del V cross del W perpendicular to del V, hence dot product will be 0. Likewise, if we are going to consider third term, this one dot this one dot this one, this is the second term, third term, this one dot this one, here this entire will be 0. Why? This cross product, whatever the vector we are going to get, that will be perpendicular to the del W, clearly written, because this is perpendicular to del W, hence dot product will be 0. So this will be 0. So in our equation number 5, this term will be 0. So what we are going to get? We can get, now the equation number 5 will be del dot A1 H2 H3 del V cross del W will be only the first term we can get, this one, del V cross del W dot this one, del V cross del W dot here del by del U of A1 H2 H3 du del U, this can be written initial first and then this one second. So same thing it has been written, del U into del U by del U, del by del U of A1 H2 H3, right? Also we have been we already know that del V is nothing but E2 cap by H2. Okay, del V is nothing but E2 cap by H2. We can substitute over here del W E3 cap by H3, E3 cap by H3 can be substituted over here. Del U nothing but E1 cap by H1 can be substituted over here. Okay, so here you can see H2 H3 H1 3 are constant taken outside, and E2 cap cross E3 cap is nothing but your E1 cap, right? That we know previously. E2 cap cross E3 cap is nothing but E1 cap. So instead of E2 cross E3, E2 cap cross E3 cap, we can write E1 cap, again dot E1 cap will be 1. So we can get 1 by H2 H3 H1 into del by del U of A1 H2 H3. Let this equation number 6. So here you can see that this equation number 6 is nothing but the simplification of first term of equation number 1. Here you can see first term of equation number 1 is nothing but this one. This, after simplification, we found, see, del dot A1 H2 H3 del V cross del W will be this much, equation number 6. Similarly, by considering second term and third term of equation number 1, what we can found? Similarly, considering second term of equation number 1, we can get del dot second term H2 H3 H1 del W cross del U will be how much? H2 H3 1 by H2 H3 H1 del by del V of H2 H3 H1. So how you are going to remember? You can see that here A1 H2 H3. So 1 by H1 H2 H3, right? So if here it is A2 H3 H1, so this will be 1 by H2 2 3 1 H2 H3 H1 del by del V, because second term is your del by del V of whatever here that we are going to write. Likewise, considering third term, here third term of equation number 1 A3 H1 H2 into del U cross del V will be 1 by H3 H1 H2 H3 H1 H2 del by del W of A3 H1 H2 A3 H1 H2. Let this is your equation number 8. So first, second and third term after simplification of equation number 1 we got this one, equation number 6, equation number 7 and equation number 8. Now we are going to substitute 6 7 8 in equation number 1. Final equation number 1 will be by using 6 7 8 will be how much? Here you can see I am just going to add the 6 7 8. So here in your 6 7 8 1 by H1 H2 H3 are common. In 1 by H1 H2 H3, here 1 by H1 H2 H3, here 1 by H1 H2 H3 can be taken outside. Then in your equation number 6 del by del U of A1 H2 H3, equation number 7 del by del V of A2 H3 H1, equation number 8 A3 H1 H2 del by del W A3 H1 H2. So this is the required expression of divergence in OCCS or in your orthogonal collinear coordinate system. Thank you so much for watching this video. I suggest watch carefully, write down the note. Ready for the next class, we are going to discuss curl in terms of orthogonal collinear coordinate system.